This is the Amp Hour Podcast. Released February 28th, 2021. Episode 532. Sponsored by Keysight Technologies. Recalling Recalls.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
What's up, nerd?
Hey, man. I saw your new fancy toy, your new video fancy toy.
My new video fancy toy, A10 Mini.
Got a little jealousy going on this side of the pond.
Yes.
Yeah.
Well, I had known about these, but you sort of like prompted me, hey, are you going to get one of these? And
yeah, the newer version was cool because it's got the individual channel recording, which is
yes, that's right. I had seen it. I didn't know about the individual channel recordings. People don't know what we're talking about. The Black Magic, designed in Australia. Not sure if it's made here. It doesn't actually have where it's made on it. So I'm not. Yeah, I find that really annoying. Anyway, I do know they do make stuff here, but I don't know if like Rode they make almost everything here.
Oh, really? Okay.
Anyway, Black Magic. Yes, design. They've got their cinema cameras, of course. They do, famously, it's not like your Sonys and your Canons are the only ones who make cameras. Yeah, little Black Magic in Australia make them too, and they're bloody good.
Yeah. Absolutely
incredible. Well, they make all these video switch-in equipment and stuff. And this is a little, 4 HDMI inputs to HDMI output, plus it simulates a webcam, and it does live streaming. And as you said, the new ISO model records all the raw footage to a solid state USB drive, which is, really cool. So it's like a one-stop, editing shop for streamers and, people like us who make content.
I think even these days, so many people have to do I think about internal trainings at companies, it's just so tough to, there's a ton of new web tools for this sort of thing, but just thinking about if you were trying to train up your coworkers these days, to do it all remotely, most people aren't geared up for that. And it's just, I think this is one of the silver linings of the, everybody being remote is just there's more tools coming out. There's more servicing of remote video needs. So that's a nice little bonus in all the shit that's happening. So
the thing I really like about it is that it's a hardware solution because I use XSplit for my recording. I also use OBS as well. Most people use OBS, but I've been using XSplit for years. They're basically identical bits of software. OBS copied the XSplit interface and stuff. But anyway, and I'm always having problems with it. Doesn't matter if it's OBS or it's XSplit. There's always it's a PC. PCs are just a pain in the ass. They they're general purpose computers.
Yeah,
right? They're general purpose computers. They crash and they're not.
The right tool for the job, right?
No, right? There's so many layers of software complexity just to do a screen capture or just to record your microphone. It's just nuts. Yeah. Whereas this hardware, this is like a dedicated box. It just sits on your bench. It powers on instantly, and you press record, and it goes, and it just records the audio and video, and you can do the live camera switching. And if you need to edit later, it can. It has the raw copies of all the files, but geez, so I'm yet to set it up because it's actually quite an effort to set up. I was just talking, it'll probably take me days to set it up properly and get it.
Yeah. Well, you have torn it down though, and I like that. And
I have torn it down, and here's the interesting thing: is people think, because this thing's tiny, you get it, and it's just this little tiny box with a bunch of buttons and a few HDMI inputs, and you think, it should sell for $100. No, it's actually $1,200. Right? Yeah. Aussie bucks. And it's wow, where's the cost? And you open it up and you go, wow, okay, here's the cost. It's got an $1,800 one-off price from DigiKey, of course. But it's got the Zinc, the Xilinx Zinc. It's got one of the top of the line Zinc chips in it. And it's it is $1,800 one-off cost.
Yeah.
Just from DigiKey.
That's what I wanted to bring up about it too. Is I love that you took it all apart. You saw that there's a Zinc in there. I feel like this is one of those things too, where you hear about these parts, you hear about FPGAs, high-end FPGAs, and you're like, what are people using with these things? And I feel like this is maybe a perfect example for it.
It is. I think so. Yeah.
Yeah, it's got 4 channels, right? So it's doing 4 channels of high throughput video. And so whenever I think FPGA, I think high-end FPGA, I think of like data pipelines. And that's almost
data throughput is
exactly
one
what
of the
this
big
is.
things. You aren't
Yeah.
doing it for just like the old CPLD stuff of like logic
Right.
switching,
Exactly.
just just replacing a few chips. No, it's data processing, data throughput, parallelism.
Right. And so there might be inline encoding, there might be
Yep.
inline mixing. So thinking about you have two video streams of high data rate video that's getting mixed together, overlaying. You think about fading from one image to another. It's like,
Fading
oh,
one to the other, chroma key in, doing the green screen chroma key.
exactly.
I speculated this in the software. Would they be doing that in the FPGA, the chroma key in, or would they be doing that in? Because this thing has 6 ARM processors in it.
Right.
6.
Right.
It's got 4 applications processors, as they call it, applications in quote marks, and it's got 2, or it might be the other way around, 2 real-time processors, and one's an ARM A53 and the other's an AM3 or something, Cortex or whatever. It's got 6 bloody, hard processors in it. This is insane.
Yeah, it's crazy. Yeah.
Yeah. No wonder this thing is $1,800 one-off price for the chip.
Well, yeah. I mean, they're not simple parts at the very least. I think.
Absolutely incredible.
Then on the quad core type processor, very realistically could be running Linux on there as well. So then you have, some kind of handling for all the USB stack and the Ethernet stack and stuff like that.
Well, is that a coincidence? There's 4 application cores and there's 4 HDMI inputs. Is that a coinky dink, right? And there's 2 other real-time cores that can just run all the background stuff. So maybe they do actually dedicate an ARM core to doing like green screen and stuff like that.
Maybe, yeah.
Who knows? But
I would think that kind of stuff is, probably running Linux and probably doing general purpose
computing.
I'm
sure it's running Linux.
Just because then you can start to run, you could write software that's, you could simulate elsewhere instead of having to run it on device and that sort of thing.
Yeah. It just makes the development much easier.
Yeah. I think, and then from a, again, like I think the other thing that's exciting about this sort of thing, there's FPGAs out in the world. I always think about the military applications, any kind of vision type thing. There's tons of FPGAs, and those, again, because of these like pipelines.
We've used them for beamforming when I was in the military, all the underwater sonar, that's one of the classic cases is, you've got like, 2,000 sensors coming in.
Convolution matrices.
And and it's just when you got to do beamforming of a couple of thousand or a couple of hundred sensors, it's like, you do that in an FPGA. You don't want to be doing that in a sequential processor environment. It's just not.
Right. Yeah.
It's not going to work.
Yeah. So that's cool.
Well, you can get it to work at like, 2 frames per second or something like that, right? But you can't get it working in real time sort of thing. Yeah. So, yeah.
Yeah. Well, and so the other thing I wonder about though is, so now you've got this application side processor, maybe a full OS on there, that sort of thing. Like, so then a device like that, you didn't ask this in your video, but I wonder how different the ISO is, right? The one that can actually record it for individual streams versus just the one that streams for and mixes 4 streams. Because
I did actually mention that in the video because there's a $400 price difference. Yeah, it's tucked in there somewhere. There's $400 price difference. I think it's right at the end, maybe. And so it's like this is where you would not be building in, like you would not have the same hardware. Like you would you would put in a different chip, like because the chip could cost you a couple of $100 difference in the BOM cost between one that's got X amount of fabric and X amount of cores and X amount of memory and stuff like that, and a lower end one in that same family. There can be a couple hundred different dollars difference. So you're not going to just whack in the higher end one in your BOM. I don't think.
I don't know. Well, I maybe not, but I'm just thinking like maybe you cost down later, but I was just thinking. So I had a convergent design Apollo, which was like a similar like video mixer. Basically, it was like what you have there. It's a video mixer, but it also had like TFT on it with a touch screen where you could basically touch to switch channels, right? So very similar in a lot of ways, about 2 or 3x the cost, and it came out earlier. But the whole thing was I bought the upgrade to this Apollo version from a different version, and it was literally just a firmware upgrade. And so much like the scope makers do, the video makers do this as well. And they release upgrades later, and then they also have these, $400 is not a small, that's, I think you said what, like like a quarter of the cost at that point.
Yeah,
So,
yeah,
or
exactly.
a third. Yeah. So
Yeah,
it's crazy.
yeah, a third of the cost. Yeah, just because literally the only difference between those two models is that one can live record all of the channels. It can like full record all of the channels, whereas the $400 cheaper one can only record the output stream. It can't record the output stream plus the original inputs. So I think that is the major difference between it. So I don't know. I suspect it would not surprise me at all if they physically use a different zinc.
Yeah, maybe. Yeah. Yeah. I mean, you're right. It's not us. Yeah. That is an expensive part. No doubt about that.
Yep.
So,
Oh, it is 90% of the BOM cost, right?
Yeah.
It's like, yeah. So I don't know. I would love to know that the price that they're getting those for. Yeah, it's $1,800 one off at DigiKey. I'd love to know, but
Sure,
it's not like it comes down to $20 or something.
No,
it's
yeah,
it's
yeah.
there's I guarantee
$200 maybe,
they're still paying a couple $100 minimum.
Yeah.
Yeah, exactly. So
Yeah, that's cool. It's good teardown.
Yeah,
Good.
but
Enjoyed it.
Yeah, it's So they're not. I don't think they're price gouging on that, because it's like, I think they're charging quite a reasonable cost considering that the other equivalent professional gear, like high end stuff, you get to do exactly the same thing. It's like 4 or 5 times the cost.
Oh,
right?
Yeah, exactly. Yeah,
And,
like I said, I had one that was $3,500 from past work, and
right.
similar. Nothing. Fewer features and stuff like that too. I think it just came out earlier. So
exactly.
I think we're just
technology wasn't
this
there.
is like it just is coming down in price because parts getting cheaper.
Yep.
Parts are more accessible, that sort of thing. So it's great.
And I think probably one of the reasons why you're not going to see like cheap like clones of these sorts of products is because just the sheer amount of software development required that goes into this. I can't imagine the effort that goes into they can copy the hardware, right? Some company come along and just copy the hardware, but to really, there's a lot of software and firmware that goes into something like this. There's a crap ton of development that goes into it. So
I think if you are making products, this is the way to differentiate, like to have FPGA bitstream similar. You might have a cloner, but you're probably not going to have direct competitors like trying to rip you off like that.
No,
I think
with actually writing their own software. Yeah,
right. Exactly.
That's right.
Yep.
From scratch, because it's just it requires a development team of
and then you do you also turn on the security features, but even if you do that, you can start to separate yourself from the pack with algorithm differences, feature differences. I mean, at this point, like you could literally get a new firmware build that has new FPGA fabric in it that does something else interesting.
Of course.
Maybe it could do 4K mixing instead of 1080p, that sort of thing. So it's just a matter of efficiency over time. And, when I think about it, I also think about like, software burn down charts. It's like, okay, we got this thing working. It's out the door. Let's go and update it so that we can add another feature, like a true software feature, and yet something that could up the cost or up the selling price rather, because it can do more. So, cool.
Anyway, I like it. I'm yet to actually use it in anger because, as I said, it actually requires a lot of effort to set up a proper rig properly. Actually, you've got to have the right cables and they've got to have the right lengths to go places. So I probably don't have I have the ability to cobble it together, but not the ability to set it up nice. I'll have to buy dedicated length cables and things, because cameras have to go from one side of the lab to the other, and they're just doing stuff like that. So yeah, man, got to go and hit that supply chain. Anyway, that's going to be nice. I'm just looking.
How is your supply chain doing these days, Dave? I feel like we should check in the era of Chipageddon.
For a lot of my products, not huge differences at the moment. For one product there is, but it's doing okay. It's just the normal production delays. I put in an order and my product comes in a couple of months later. It's I actually need to optimize my warehousing better, warehousing in quote marks,
predictive ordering. And we've talked about that.
Exactly. Because I so often I've been doing this for years. It's like, all of a sudden, geez, I'm running out of stock. Oh boy, it's a 2-month lead time for ordering new meters, or whatever. It's just like even something simple like test leads, for example, right?
Sure.
You think, I was buying the Bryman test leads at one point. It was like, oh, sorry, we can't. They're a 2-3 month lead time. It's like for a test lead, like holy crap,
And that's not even
like,
a automatically retracting test lead like you said you're
no,
going
it's
to make
not
for me.
something fancy. No, it's just a regular
something that doesn't exist yet. Yeah.
But it's it's crazy. Yeah, lead times. Anyway, yep.
Yeah,
it's tricky.
I got hit by so there's been ice storms here in the States, and obviously I don't know the power outage. I don't know if you read about that down in Texas as well. But
here's the thing, right? I first learned about this Texas snowstorm thing from the Bit Guys. He does vintage computer stuff, right? And he did, his house has been ruined. His house got flooded or something. So that popped up, and he went, in Texas we're having these snowstorms, and I just went, it snows in Texas.
Right.
Like I had no idea. Refrain, like to me, foreigner, it's like, no, Texas is like, the equivalent to the outback here. It's just, hot desert and bloody. Yeah, I had no idea.
Mm-hmm. Yep. I was like, about every 5 or 6 years,
right? You'll get a freak.
They get hit. Yeah.
Right. And wow.
I used to live in Texas.
Is this like northern Texas or lower Texas?
This was all of Texas.
All of Texas. Wow, I thought there would have been
the whole South got hit. This was a really big deal.
South of Texas. That's practically on that's the Mexico border.
Yeah,
What the? I had no idea.
Weather systems, climate change, it's like a thing. It goes both ways, really hot and really cold. So there was a system that dropped down there and just dumped a bunch of...
Wow,
that's so I used to live in Texas, and I have never been as frightened as driving on the roads when there's been ice. I was driving a little Honda Civic. On the roads with all these Texans with their trucks and yeehawing past me and just seeing cars slide off the road. Man.
That's scary. Yep.
Yeah.
Wow.
So no, it's very unfortunate. There was a lot of loss of life, unfortunately, as well.
I saw that huge pile up. Yeah, that was incredible. I saw the video of it. Wow, that was just.
Oh, not just that. I mean, just because the power got shut off a bunch of places too. So I don't know how extensive you heard about, but it was the whole Texas grid pretty much got taken down. And
once again, I only find out, because I'm not following US local news or whatever. I only find out because somebody on Twitter, I think it was Lawrence Krauss or somebody, I follow some physicist and he lives there, and he said, I've been without power for a week now.
I didn't know he lives there.
It's
he used to be a professor at my university. I don't know if you knew that.
Okay. Yeah. He was the physics professor. Yeah, that's right. Yeah. No, I think it's someone I follow on Twitter. I don't think, maybe wrong about Lawrence Krauss, but somebody said, yep, it's been a week, no power. Holy crap.
Yeah.
The longest here in Sydney, because I've lived in Sydney all my life, the longest we've ever been without power is probably in my entire lifetime is probably half a day.
Do you guys bury lines there or no?
It depends on the suburb. Older suburbs, no. Newer suburbs, which when I say newer, my suburb's 30 years old. Yes, we have buried cables. So
yeah. So in Texas, you can't do that a lot of places because it's bedrock. So
right, okay, yeah.
So that's one thing, and then but the real thing was that at the actual a lot of the diesel generators froze up, and a lot of everything got overloaded, and then they have their own grid, and it's just all this crazy stuff that I don't really understand, but I do know that it was not ready. It was not ready, unfortunately.
Right.
So it almost is like an economics thing. It feels like more than it was a like an electrical thing. It wasn't like they didn't have the.
You guys have a lot of politics in your grids, in your grid management over there. Yeah. It's yes, all of California's shut down. Sorry, not because of a line problems. It's because of energy bartering, trading things. Sorry,
Yeah, I don't remember that, but
that was a big thing a long time ago.
PG&E has got their own issues out there. So
anyway.
No, it's unfortunate, but it's I'm glad it's all back on and people are recovering. Hopefully.
Yeah, it's crazy. It shows how dependent we are if the power goes out.
Yeah.
So I am upgrading my solar system. So
I wonder if that's going to drive future things like that. So like, thinking about Texas now, I have a friend who works in, the power service industry and stuff like that. And just seeing if
Yep.
I asked him if they've seen an uptick in just general interest in it. And he said, yeah, they have seen some more interest in just kind of like it was, they don't, this was not a battery system, but just general, like people having this near term focus on power.
Yep.
And I do wonder about that longer term of just, people building out their own battery systems if they have the capability and just kind of self-reliance in that way, because it's like, if you can't get reliable power, especially at the most emergency times, it's like, oh, then what? Like it's tough.
Well, see, the thing is, it's not just, your life goes back to normal if you've got a battery system. Yeah, your house stays up, your fridges are still working, and you can still use your computers, but you may not be able to use the internet because that's got to go to the local, it's got to go to the local cell tower. And if the whole state or the whole city's out, like, well, no, you're not going to get phone or internet either.
Right. It's only if you got what's the
satellite Starlink.
Yeah.
Starlink, Starlink.
Yeah, I mean that's another like
No, sure. No, if you want to be totally autonomous,
yeah.
If you're living in the middle of nowhere, well, even if you're not living in the middle of nowhere, because as I said, I'm upgrading my solar system. I'm going to be getting I'm going to have a total 8.5 kilowatts, I think, system now, and it's like now I'll be able to get a battery, because then it makes sense. Whereas before we were using all the energy, having a battery system was pointless because we were sucking all the energy.
Yeah, you'd never actually use it.
Yeah,
or you never over capacity it.
No, exactly.
Yeah. So then, what's your thinking on the battery side?
Well, yeah, I will. Well, I'll get the solar system installed first. I'll run it for a couple of months. I'll look at how much excess energy we're feeding back into the grid, and then I'll be able to calculate how much we're, can actually store and then reuse during the night and stuff like that. But, like battery systems aren't cheap, and they're probably not going to pay for themselves. Like,
interestingly, one of my buddies is talking about like solar and battery as like a hedge against inflation. Like, obviously the US has a lot of economic things right now where we're spending a lot of government dollars, and whatever you feel about that, I think more dollars in means potentially higher inflation. But he's like, look, if money's worth less in the future and I buy something that has real value now that actually generates power, then that actually is a pretty interesting idea.
I know, long term. You've got to think long term.
Yeah, exactly. Yeah. And like, I love that idea personally of just like, first off, you get like the nerdy thing of like solar and batteries and like some like, like resources for yourself. Cool. And then also it gets quote unquote cheaper over time, which is, not, this kind of a mind game, but whatever. And then it also generates power. It's like potentially money. So that's cool.
Well, I ran the numbers on this new system, and it's like, well, it saves us $40,000 over the next over the lifespan of the panels, which is 20 years over the warranty period of the panels.
Mm-hmm. Yep.
It's like it's like $40,000 that's in today's money, not in guaranteed inflation money in the future, because the way the money printer's going, brr, it's like, it's not.
That's right, kids. Dave knows memes.
You're not going to avoid it. Exactly. I'm the meme lord. I'm not quite Elon Musk level, but I do know and appreciate my memes.
Here on the Amp Hour, we look for sponsors who are interested in teaching our audience. This week, our sponsor is Keysight Technologies, who are ramping up a new contest called Stump the Experts, which is focused on Keysight's 5G testing technologies. I had the opportunity to talk with Martha Zamid, who is a longtime Keysight FAE who now focuses on 5G. I started by asking what her typical day looks like.
I work with customers, so I get to see what they're developing and what they're actually, testing, and then I take that into our design team to make sure that our solutions will be able to support what customers are working on.
Before we stump any experts, let's get unstumped ourselves about how 5G works. Where's Martha focusing in the technology stack?
My focus is on the physical layer. That's the air interface side of things. The biggest challenge with 5G NR compared to any of the previous generation, one is the frequency that it operates in. With all previous generation cellular technologies, everything operates in the RF, mostly below 3 gigahertz frequency. But because the RF side is pretty populated, there isn't enough spectrum to support 5G NR. 5G also uses millimeter wave technologies, and that's never been used for cellular technologies. So that is a new area for our customers. Operating in millimeter wave, does provide you with a very wide bandwidth. There is a lot of spectrum available because, again, it has never been used for cellular technologies. So it provides the operators enough bandwidth to be able to support extremely high throughput. So that's the good thing about it. But the challenging part is all of the propagation that happens in millimeter wave limits, how far the signal can go. So you won't be able to have as much coverage as you do in the RF frequencies below the 3 gigahertz.
So what's the hard part about 5G?
From what I do and from the physical layer aspect, one challenges are the frequency, being able to make measurements in millimeter wave. The other is the bandwidth, right? Now you're dealing with an extremely high bandwidth. Just to give you an example, for LTE, when we look at a single carrier, the maximum bandwidth was 20 megahertz. But now with 5GNR, when we look at it in FR2, it's 400 megahertz wide signal.
Yeah,
so
wow.
the challenge is in achieving almost as good performance as an LTE, but at a very wide bandwidth. And you always have to deal with the wider the bandwidth, the noise that you have to deal with. Having test equipment that has extremely good performance at a very high frequency and at a very wide bandwidth is our own challenge, right, from a test and measurement. And then similarly for our customers, as for their devices and for their base stations to achieve.
Keysight's new contest wants you to ask questions to stump the experts by recording a short video about a range of 5G and test questions. Early signups can win a t-shirt, and contest winners will win consulting time with some of the Keysight experts. Some participants will also win books about 5G. To learn more and enter the contest, head to theamphour.com/5G, and that'll take you to the contest page. And now, back to the show. Did you see Martin Lurton's thing about like inspecting solar panels?
No. Inspecting them how?
I think he was shines like a UV light at them, and then
I saw
takes,
he developed a measurement box or something for them.
Yeah, there's that. That was a while ago, but this was so. Martin's been on the show before here, and
Yep.
Dave actually introduced me to Martin when he was living in Cleveland, and he's basically, I think he's doing like he took the filter off a camera so it captures more UV. I think,
Yep, right.
And then he's shining light at it, and then seeing like these cracks, and it actually he has like damaged panels, and it's super interesting. I've never seen anything.
That's fascinating.
I think he actually mentioned your micrometeor strike.
Oh yeah, video.
In some of his videos too.
Right.
Yeah. So.
Yeah, I wouldn't know that you'd get like invisible micro cracks. So they usually they're either like 100% tough or they completely shatter. Like,
Yeah, like a spider crack kind of thing. Yeah.
Yeah,
so
yeah.
It's just it's really interesting. I mean, like
Wow,
I feel like there's like this whole area there of like I don't understand solar still.
Well, and that's going to vary between panels because they've all got different manufacturing technology, and they're all made different, and they don't use the same glass, they don't use the same materials and stuff. So. It's very different, but so I'll actually be having a mixed hybrid system. I'll be having sort of like my system will be like 2/3 new, which is going to use the micro inverters, right? So it'll use, I'm getting new panels, it'll use the new micro inverters, but I'm going to have my existing system still running. I'm just going to move that to the other side of the roof so I pick up the morning sun. Because why? Like, it's still a great system, even though it's 7 years old. It'll run for another 15 years at least, So I'm going to use my existing string inverter and my old panels. I'm just going to reuse them. Why not? So I'm just going to pay the installer to move it to the other side of the roof so that
that's a great idea.
So that my new panels can get the best sun on the new side, on the main side. But
like the south side.
Yep.
Or whatever.
Well, no. See, my panels, people don't know this about my system. It's not even optimally north oriented. None of this south rubbish. That's for you weirdos on the other side of the planet.
Jesus.
Right, north, right? So you've got to orient your panels north. That's here, right, north. Right, north. So technically, we do have an ideal north-facing roof, right? But Mrs. EEV blog doesn't want solar panels plastered right over the nice front of the house. Yes. So ours are actually on the west side where the sun sets.
Mrs. Contextual Electronics has expressed this when I've said...
she said the same thing?
She said, she's like, look, when we buy a house, you can have solar if there's a garage that faces the right direction. I'm like,
Right,
come on.
okay,
It's free power.
Yep. Yeah, see, because we've got nice tiled roof, we've got like a nice looking tiled roof, and she doesn't want it like plastered with solar, even though she's like an eco nut and she does, she loves the solar. So she
Sure,
just
of course,
doesn't
yeah.
want it ruined, right? So so we've got it on the west side.
Got
you
it.
know.
Yep.
Yeah.
So yeah, it's just showing to the
it's-
neighbors if they're in their backyard or something like that.
Yeah,
or
like if
available on
if-
satellite.
Yeah, if you come down our driveway, you can't see. You wouldn't think that we've got a solar panel system. You just cannot see it. So
Yeah.
and that's how she likes it. So yeah,
she
it's
might be
not
right
optimal.
though. So if there's like a zombie attack, right?
Oh,
People are
right,
going to go
okay.
right for the
Right, the house that-
the solar panel houses first. So
Right. Okay.
yeah. And Google Maps won't be working because the towers will be out. Come on.
Right. Oh boy. So so I'm going to be running a hybrid
that's
system.
cool.
So that'll allow me to do like videos actually comparing, comparing like
cool,
the string inverters versus the micro inverters and all sorts of stuff.
And
so.
what is the string inverter? Is basically like you invert it after you you stack all the panels up and then you invert the higher voltage.
All the panels are in series. So a regular solar panel is about 40 odd volts, something like that. So you put them in series and it goes like my system's about 460 odd volts because I've strung 12 of them in series, right? At about 40 volts each. So it's like 460 odd volts, maximum open circuit voltage.
Yep.
Yeah, and that's actually, and so I'm pretty much at the limit. That's the limit of most string inverters. Mine's actually got 2 channels, so I could put a second string on there. But the problem with the string inverters is that if one panel gets blocked, that brings down the whole string, right? That's the advantage with the micro inverters is if one
like
panel,
Christmas lights.
Yeah, right. Yes. So that's the that's a disadvantage. So I'm going with micro inverters this time.
Yeah, and that's supposed to be better for mixing, right? Because you're mixing at the AC. You're mixing AC power that you can. Match
They are
easier, right?
AC out, because they're dedicated little inverters. So everything's low voltage. So they're actually much safer. Because 460 volts DC. I've done a video on this where my DC isolator switch actually went bust, right? And it's lucky it didn't catch fire because these are a thing, right? Because when you've got high voltage, high power DC, if that sucker arcs over. It just keeps going. A DC. That arc sustains until something catches on fire, that something is your house, right?
I was going to say probably until the carbon builds up so much that it's like, right. Oh, I'm a resistor now.
And it is bad. Like go Google. This is a good one. Go Google DC isolator, solar isolator failures or fires or whatever. Wow. So they're not that safe. So mine certainly failed, and there's been recalls of various brands have had to be recalled because they're not safe, and et cetera, et cetera. Speaking of which, there's rumor. I haven't looked into the story completely, but Hyundai, how I've got the new Ioniq EV, they might recall all of those worldwide. So due to safety
That's not good.
concerns. No, it's not good. I love my EV. I don't want to have to bloody send it back and get the battery changed or whatever, or I don't know what they have to do to it.
Or just trade the whole damn thing out, right? At that point,
I don't know, but that's really annoying. I know they've already done that in certain countries, but at the moment it hasn't hit Australia yet.
God, what a nightmare that would. Have you ever been part of a recall, like a product recall?
Yes, I did. Wow, this was a long time ago in a galaxy far, far away. Was it an AWA brand? No, or was it an RCA brand TV? I'm talking none of this LCD rubbish, right? Old school CRT. This was back in the early 1980s when, a color TV was a big thing. We were just sort of coming out of the black and white age, right? And they had to recalled RCA or somebody, can't remember who it was, recalled, and they actually sent somebody around to your house and they actually did the repair in your house. You didn't have to take it back. They actually sent someone around. Wow.
That is interesting. I actually meant on the developing a product side of things.
Right. Have I had a product recalled?
Because I mean, that's like, I feel like that's like the fear of God's like in me about that of just like, man, there's just like nothing more expensive. I feel like some of the time it's just like, well, you should just, close up shop, go home, see ya, like.
Oh, well, we had the switch problem with the 121 GW meter after the Kickstarter came out. We got all these meters. I was about to ship them, or we did ship some, and then people are going, oh, my range switch doesn't work. And, then we started getting more reports of this. And about 2% of people actually reported that their range switch is dicky. And then sure enough, we actually determined, or, Kane, actually, they're the developers of it, they actually determined that, it was the thickness of the PCB was slightly out. The thickness of the PCB from the manufacturer.
Oh, wow.
And it's like, well, we've manufactured like 4,000 of these boards, 5,000 of these boards or something. It's like, and they've all been populated with parts. So they've gone up the value chain.
The cost is much higher. Yeah.
Yeah. The cost is so, it's not like we can scrap like 4,000, if they were just blank boards, maybe, but these had been assembled, right? They got all the parts on them, So it's gone from like, okay, we scrap them at the cost of $1 per board if they're a blank board or whatever. The blank board, it's only $1 or $2, right?
Yeah.
Well, I don't know. It was $5, I think, right?
Whatever
so
it was.
It's, it's manageable cost, right? But once you populate them with all the expensive multimeter chips and all the analog parts and all the references and everything, boom, I don't know what the bare board cost is, but it's enormous, right?
Yeah.
Oh, sorry, the actual populated
board
cost.
Yeah.
Yeah. It's enormous. So we couldn't just scrap them. So we had to develop a shim system, and then I had to mail out, 2,000 of these shims, and people had to retrofit their shims to it,
Yeah, but that's just, if that's the worst a Kickstarter does, at least it's delivered and stuff like that.
Oh, and at least it's delivered. Yeah, but it's a big hit to the reputation, right? It's a huge
I get it.
hit, It's like,
yeah, that sucks still.
Yeah, it's
but
totally embarrassing.
I wouldn't call that a recall. I'd call that a.
Oh no, it is not
that's
a recall.
Mod.
No,
that's a mod. Yeah.
Yeah.
I just think about like a large scale global recall. Like, man, like how do you even deal with that? I would love to hear in the comment section if anyone has been part of a large recall like that. Just like almost like what's it like at the office? You know what I mean? Like how do you continue on from that? Does it just like everybody shifts into recall mode? Do you even keep making the next thing that you're like, you're always working on the next device as the one is being produced. So it's like, do you even bother? You're just like, oh, well, guess we won't be making anything new until we fix this old one.
Well, I'm sure it's killed companies. I would like to know if product recalls have get, because when you're like Hyundai or you're Tesla, actually Tesla, there's talk about Tesla having to recall all their cars as well. Isn't there?
Holy shit.
I think.
I don't know.
I think I read something about that. They're like, they've had to admit, apparently they've been trying to avoid it for years. And anyway. Let me
well, don't worry, the stock price will still go up.
Of course.
Completely decoupled from reality here.
Exactly.
So don't worry about that. But yeah, that's crazy. I mean, that's billions and billions and billions of dollars.
Here we go. 5th of February, Tesla has responded to a United States recall of failing touchscreens in 135,000 of its cars, arguing the units were only ever expected to last 5 years in the first place. Wow, that was their excuse. Tesla's excuse, where the touchscreen, which is the main operational thing in a Tesla, because it has no other controls.
It's dead in the water if it doesn't have that. It's like, I guess maybe you could operate it from the app at that point.
Wow, they've actually, this is breaking news. Tesla claims recalled touchscreens only expected to last 5 to 6 years. Wow.
I would say February 5th news is breaking.
Oh,
well, maybe it is in the amp hour.
Yeah, exactly.
20 days later, the amp hour reports,
Wow.
Yeah. So like in that case too, like that's, I've heard about, like, I've had recalls like that on a car that I had. And like, I guess some of that is the same thing where like they call it a recall. And then it's like, you have to go to a service station. And I think it was like a car, maybe it was a Hyundai I had at one point or something like that. No, it was a Mitsubishi I had, where it was like, the airbag switch in the car had to be switched out. So it was just you had to go in and get that switched out, and it was free.
What about the Takaka, if I'm pronouncing that correctly, airbags incident? Have you heard about that? I don't know if it came into the US, but anyway, there's this. Is it Takaka Airbags? Is the company?
How do you? Oh, that's like the OEM.
Yeah, that is the OEM of these airbags. Yeah, the airbag recall. They went into all of
Takata,
Mitsubishi's cars, Ford, I think Toyota, they're like the OEM. They're like the big airbag OEM. Takaka and Takata.
Takata, like
Yes. And this was
name.
a huge, Japanese brand. And they had to recall like every single airbag. And this hit like
67 million.
67
my
million.
Gosh.
Yeah. And it's like,
wow.
And I think, don't quote me if I like, but the head had to resign or something else happened to him. And like,
oh my gosh.
like this was like, because in Japan, like, face is like everything, it's like, and it was like,
dude's not getting another job after that. Oh my gosh.
Oh no. It's like, and this was, 17 people have died apparently from these, and 200 injuries from these airbags just like exploding, just actually going off. So in Australia here, 130,000 cars were actually recalled just in Australia due to these airbag things.
Oh my gosh.
Due to this one manufacturer. Yeah.
Wow.
They've got 50,000 employees at this Takata. Wow. So they're a huge company.
I just, man, like that high reliability, like long-term type stuff like this too. Like,
how do you deal with it?
It scares the bejesus out of me. Like, and I like, I have clients that are like industrial and like, it's just like, man, that is what keeps me up at night. Like, the supply stuff we talk about, that is sure. That's a short-term hassle and risk and but man, this stuff really, really
got a big story about this. I've done a video on it like 12 years ago. It's one of my original videos, but can I tell the story again? Yes, I was working for
at 12 years you start to recycle.
Tallies
or two.
And it's due to a rubber band. I think the title of my video is how a rubber band caused, like a $20 million recall or something.
Gosh.
It's I can't remember the exact title, but
how
if
a
you
rubber band costs millions of dollars.
Millions of dollars. How a rubber band caused millions of dollars. And the breakdown is doing these underwater sonar stuff, right? Underwater seismic survey streamers, right? They're actually 100 meters long. They're giant, right? We've got a giant factory 150 meters long that manufactures these 100-meter long things, right? And anyway, so we manufacture these things and we send them out there. Once they get out on the boats, they're towed underwater behind the seismic survey boats searching for oil, right? And they all started to, like, their noise performance, like they just got like noisier and noisier, right? Because these have some of the world's quietest analog to digital converters, right? They have to be, you're trying to hear these echoes, like, the noise floor is like minus 136 dB or something, right? It's like the world's lowest noise floor stuff, which is some of the designs I worked on. And it's incredible. So the noise floor started to go up, right? Not by much, but it's like, but it's enough to ruin your data.
Percentages, right?
Yeah. Like it goes up 5%, and that's enough to find oil or not find oil, right? And so it's not like it failed. Its performance just degraded a little bit. And then, we did all our so the customer's complaining because these are failing out in the field, and every day that ship isn't working is cost like $100,000 a day to just run it, just to keep it operational.
Sure.
And or hundreds of thousands of dollars. So anyway, so we did our investigations and we found that inside the hydrophone, right, we use these, we manufactured our own ceramic hydrophones. They're little, and they're inside these oil-filled pouches, right? They're, it's about half a foot long or something, 30 centimeters, 15 centimeters long, big oil-filled pouch, and that allows the acoustic waves from the water to travel through the oil into the hydrophones inside, right? And then what we did is of course, these wires coming out of these hydrophones, and we actually taped them down, or we held them down with rubber bands. Right? Just so that when you put the outer shells on, it didn't, the wires didn't get pinched and everything else, right? So we're just using these rubber bands inside to hold down these wires, and we didn't think anything of it. But the actual acoustic design of this, of how the shell works, the oil has to flow through one side and everything else, and, there's a certain acoustic design to it. And these rubber bands, the oil inside actually made the rubber bands swell up over time, and they swelled up enough to actually block some of the flow of the oil inside. So it was like, so the hydrophone became unbalanced, so to speak, and the oil didn't flow properly through the whole thing, and it caused an increase in noise and actual, the performance to actually degrade and everything else. So a bloody rubber band cause this, it's just nuts. Like,
yeah, that's bonkers.
and so we had to not recall these streamers, and we had to actually cut them out. So we had to develop procedures because these things are like sealed. Like there's a gigantic outer sheath 100 meters long. So we had to develop techniques to actually repair these, which involved actually getting a scalpel, cutting open, like it's like surgery, right? Cutting open this outer sheath.
Yeah, this is totally a recall story here, I think, Dave.
Right.
This
and
is
then and then actually pulling the sheath back. So and then we had to develop the tools to actually grip the sheath to actually pull it back because you couldn't do it by hand, right? So you had to open the thing up. This is like open heart surgery on the product, right? We had to develop the tools to actually repair them, right?
Yeah.
And then we had to go in there and we had to, strip it all out. And then we had to develop molding systems that, because you couldn't recover the entire 100-meter long streamer. So we had to develop, once again, jigs to actually weld the polyurethane back in place to actually seal up the weld and everything, to actually weld it, weld the polyurethane material, I don't know what it was. But and actually seal these things back up. So we had to. It was just incredible. It was a huge operation. It was absolutely enormous. Cost us like I don't know how many untold millions.
Spared no expense, huh?
And it was nuts. So we had to do and I actually had to develop custom hardware and software to measure the performance.
I was wondering because your video mentions DMMs. I'm like, where is the DMM in this story?
Right. Well, because this streamer, right, and picture it, it's 100 meters long, and it's got I can't remember the exact number, like 50 hydrophones. Like there's a hydrophone every meter or two, right? Yep. It's actually to do with the wavelength of the frequencies we're trying to measure and stuff like that, right? It's all wave acoustics and whatnot. So there's a lot of these streamers, but because they're all in parallel. Right, all these streamers are in parallel. We didn't know which ones were failing, right? So we didn't know which one. And you couldn't just replace them all, right? That would have been, you may as well make the product again from scratch. So I had to develop a jig and software with a differential speaker solution that would actually clamp over. So this big thing that clamped over had a couple of speakers, and I'd drive them differentially on each side so that we could work out if one of the ports was actually blocked, and then hook it up to a system and measure its performance and everything else, and we could actually determine whether or not that individual hydrophone was actually busted. And then and then it was a trade-off, right? Because they're all in parallel, you couldn't just waste, and here's the thing, you couldn't just waste money repairing every one that failed, right? Because there was no hard threshold where, well, if it's over this value, we need to replace it. It's only when you combine it with all the others in parallel can you make a determination of whether or not that one's worthy of actually replacing, because it was X amount of cost to replace one of these hydrophones, right? And you couldn't just go and replace it. So I had to write and optimize this software that actually predicted what the noise performance would be over when they're all in parallel, and go, well, if we replace this one here and this one there and that one, it'll just bring it below the overall threshold. So my software had to actually predict how many to replace and where to replace them. And it was, wow.
That's intense. Yeah.
It's absolutely crazy. So that's a very, very unique story, I think, in terms of, it's not, something just hasn't failed. It's just performance is degraded, and yet you could actually leave degraded ones in there and it would still meet spec.
Right. Yeah, it's some maintenance over time kind of thing, and also it's almost like a statistical kind of thing. Yeah.
But that was a huge hit to the company rep, the company reputation. Right. And there's only like 3 companies in the entire world that do this stuff, right?
Right, exactly. So everybody heard about it, everybody knew it happened.
Everyone knows about it, and
and it's brought up at the next time someone's trying to sell something too, I'm sure. So
but I guess the only saving grace is that the customer couldn't just go, well, bugger off, we're going to go with your competitor. It's like because they're invested for hundreds of millions of dollars into your system, right? Into your ecosystem, which is not just the product; it's all the gear that goes along with it.
Yeah.
So they can't just, change on a dime. So but yeah, we lost don't know how much money we lost on that, but geez, that was.
On the DMM front, so you mentioned DMMs now.
Oh yes, I saw this.
Yeah, the new Marco Reps video. You saw that?
Speaking about high end, yes,
Oh,
high end, like
man.
world's best performance or whatever. Yeah, the 8.5 digit voltmeter. But this is not his design, is it? Was it someone
That's
on the
correct.
EV blog forum? Right, he just built one up.
So this is CERN. So CERN actually developed this open source,
Oh, okay, right.
8.5 digit. They're calling it a voltmeter. I'd say it's actually more like, I mean, there is a voltmeter, but it's really like so it's like minus 10 to 10 volts. And so it's basically like an ADC input effectively.
Right.
And so there's no ranging or anything like that. So it's not like a DMM, which is really, I think, how you differentiate that sort of thing and all the protection elements, everything else. However, the 8.5 digit voltmeter, holy moly. Yeah, it's I mean, so Marco does actually like the assembly of this thing. He did a bunch of circuit boards. He actually shows, he's just like tosses off like, oh, by the way, I just like did a DIY vapor phase vapor phase reflow during it. And he does machining, and it's just it's amazing. The whole thing is really amazing. So I don't know how much I have to say about this other than like
it's just amazing. Yeah, I don't know how much effort went into this one video, but it's months and months of effort.
Yeah,
into this one.
I think that the thing that really sticks out to me in this is like, people wonder like, so you have high end, like what differentiates a 3.5 digit from an 8.5 digit piece of equipment, and like from my days at Keithley, not any special input from me. It's just like it's a lot of it is sourcing really, 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 really amazing components.
Yes.
And so I forget what he calls them, but they're basically these gold encapsulated through hole dip mounted parts that are actually matched resistors.
Yes, they're actually a network of resistors. Yeah.
Yeah, and like that is often the magic you need, and
that
then
is
you need
key.
to characterize them yourself as well, and then the LTZ 1000, which is like the best reference in the world, like you mentioned, and is talked about ad nauseum on your forum. Like it's just,
but then again, you can't just whack in the LTE, and you can't just whack in that part and expect that performance, right? There's a lot of like finesse that goes into making sure that's thermally stable, structurally stable, right? Because if your PCB expands, that actually bends the legs a little bit, and bending the legs a little bit can actually degrade the performance of the part.
Sure.
Right? It's just it's insane. It's like
it's like you need all of your components in like a nice warm fuzzy spot, and really you just needed to know that it's always going to be the same too. So there's a Peltier cooler integrated as well, so like that it's their heater and cooler. So like it's definitely worth the half-hour video it is. It's really 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 good. So
well, you can probably do like a 6.5 digit meter with all off the shelf parts and get away with it, right? A decent performance 6.5. When you go from 6.5 to 7.5, now you start requiring really precision parts and knowledge. When you go from 7.5 to 8.5, you're on the bleeding edge. It's like,
I would say 6.5 is still pretty tough. I'd say 3.5 is doable, but I'd say 6.5 is still repeatable.
No,
and like,
if you do a teardown of a 6.5 digit meter, it's pretty much all off the shelf parts.
but they're still matched, and they're still
but you don't have to take thermals all that seriously.
Sure.
Like
that's true.
It's not the same level, right?
Yes,
so,
I agree with that. Right? Yeah, you're depending more on like the box that it's in is probably at an ambient temperature of 30°C or whatever it is. After, you still have your warm-up times, you still have everything. You assume stability because of the air in the box instead of the machined metal pocket like Marco did that holds the, that has this locally controlled temperature down to, a certain precision and stuff like that. But yeah, it's bonkers. I was telling someone in response to this, I really need to get some of my former coworkers on the show before they retire. So we'll try and do that. Some of the Keithley folks. I just I have an interview in the bag with Joel Dunsmore, so that's coming soon. We'll see when.
Sorry, who's that?
Joel is the guy who did the 8753, pretty much the entire VNA, not the entire thing, but he did a lot of the RF front end and everything, and he wrote a book about it as well.
Oh, really?
So,
sweet.
Yeah, so he's still a Keysight, and he's like,
he wrote a book about developing that.
He wrote a book about how to use a VNA very effectively.
Okay, right.
And it's this amazing reference. There's a new second edition out, so that episode I will continue to tease for a while, I think. But But
Yeah,
let me tell you, talking to Joel, I was so nervous. And yeah, he's great. But that kind of thing, like people who are in the industry, their just depth of knowledge is so insane like that. So yeah, it's great.
Sweet.
Yeah. And if people know other people like that, we want to talk to them, right? So please drop us a note, send us an email, feedback@theempire.com. We'd love to hear about them. There's also a form you can fill out. We do look at them all. We try and schedule with people that are suggested as well. But like those deep knowledge experts like Joel, man, yeah, I'd love to talk to someone like that, especially if you know them. That's even better.
They're terrific. Yes. Yeah. I'm trying to line up someone for the micro inverters that I was talking about, the micro inverter stuff. So
that would be great.
That's in progress. So
I remember, oh shoot, I forgot his name. We had someone on a long time ago from Cree, and Cree was doing a lot of silicon carbide stuff.
Yep.
What was his name?
Oh God.
John Edmund.
John Edmund.
That was a long time
ago.
Yeah, that was episode 71. Like how did we get him on? He was the CT. Is the CTO of Cree.
He was the CTO of Cree. Yeah, we just asked, I guess, and we.
Yeah. Anyways, so I remember when we talked to him too, like a lot of so there are IGBTs often in microinverter stages, but I remember him talking about like how this was going to be a more accessible thing as silicon carbide comes online, as more silicon carbide comes online for switching FETs. 1200 volt switching FETs are just kind of ain't no thing. And I remember that thinking about that and just how that was going to change things. And now microinverters are the normal way of doing things with solar, right? I mean, like that is most of the time what you're seeing on the back of panels versus the string, unless you're doing like a farm,
I don't know if they've hit that level yet. I think string inverters probably still dominate. I don't know. I don't actually have the data on that, but that's my gut feeling, is that strings do dominate.
Oh, sure.
Because it's cheaper. It's simply cheaper. And economics is going to win, right? It is not cheaper to get these micro inverters, right? It's more expensive.
Okay.
So,
all right.
Yeah.
One of my buddies from high school ended up, he's a solar salesman now, which is like, especially in Illinois, it's like so weird that he's here and like selling in Illinois, but he's like killing it in Illinois.
Yep.
And like, it's weird that it's a thing, like I said, but also like I'll have to ask him about that to see what kind of systems he's selling, just because like that's
right.
Might be different here versus there versus, what are the broad trends. So,
and most people, Joe Average is going to go for cost. Right. Joe Average doesn't give a crap whether they're micro inverters or it's a string inverter or what brands they are or what, they just don't care. They go, how much warranty do I get and how much does it cost?
Right.
That's it. Right. Yep. So there's a lot of, I've mentioned this before, right? Solar resellers in Australia, over 500 of them have gone out of business. Right.
Wow.
It is.
That's crazy.
Yeah. Like so many, you can't almost count them. Right? It is, because they spring up when some government program comes in and then every man and his dog is selling, solar systems, is actually, installing and selling solar systems. And then the rebate finishes and boom, all these companies just vanish along with their warranties, So it's like, Yep.
Huh.
You have to be careful. It's a bit of a, All right, we've got we've shows and we've almost done our dash, dude. And we've got so much more to talk about. There's so much more news. Well, come on.
What do you want to talk about next?
Oh, well, bloody Perseverance landed, for goodness sake.
Oh, jeez, yeah. Oh, yeah, blah, blah, blah. Another planet, no big deal. That was friggin' amazing.
I live streamed it. And it was just, I think at the start
I don't think
of
anyone
stream,
listening to this is going to be like surprised. They're like, oh my God, we landed on Mars again?
No. It's like, at the start of the stream, I think I put the odds at like 85% plus because they had already done it. It's almost essentially the same airframe, but things were different,
Oh,
it was
so
the same
awesome
landing system, but they did. Yeah.
I loved
they
it.
just nailed it. They just nailed it. Again, it's like, and you got to understand the sheer size of this thing. It's a car, right?
Yeah.
It's the size
not a small
of a car.
either.
No, it's the size of a large SUV that weighs like 1.5 tons or something, right?
Yeah.
And they just landed that sucker on the surface of Mars. Just unbelievable.
I don't know how much we have to say about the electronics in general. Do we? I don't know. I mean, that's the thing. I was just like mouth agape, of course. But
one of the interesting things is that they used off-the-shelf FLIR cameras. That footage that you see of the sky crane coming down, they actually, they didn't use special stuff. They used FLIR, not infrared. Apparently, FLIR make some regular industrial cameras. I guess
sure. probably very, very strenuously tested.
Oh, I'm
cameras,
sure
right?
they would have been, qualified, but but technically you can buy exactly the same camera that was, the commercial vision camera that was on. I think they had like 6 or 8 cameras just watching the landing. They had multiple ones on the back shell, multiple ones on the rover looking up, so you could see the parachutes and all sorts of stuff. And yeah, these were just off the shelf cameras because like it wasn't a priority of the mission, so I guess they didn't want to spend a huge amount of money in development. Developing like it's not like the actual.
Why go custom? Yeah, it's not for the science.
No,
it's just
no,
for the,
no,
it's
it's not for the science.
The marketing.
It's just for the marketing and the
marketing
laurels,
camera.
right? Yeah, exactly. So yeah, they wanted to spend as little as possible. So if they, and that's why they have multiple ones, because if 4 of them failed, who cares? Well, you've got another 4. It's like that was just that was amazing. So yep, it worked.
Yeah,
I was surprised how quickly it all happened. Like, because I wasn't there for the previous one. I wasn't there live for the previous one, unfortunately. I'm still scarred from that incident. But yes, it was. I was just like surprised how like it was all like I was there live streaming. And I'm going, oh, okay, they're 300 meters up, and next like 5 seconds later, it's landed, touchdown, like boom.
I mean, that thing it was burning fast, man. It was going.
I couldn't believe how quickly it all unfolded. So it was almost an anticlimax because like there wasn't enough time to build up the tension. Almost, it was like
should have opened the feed sooner.
I blinked and I missed it.
Yeah.
Anyway, very cool. So that's landed. So yep, fantastic. Another science lab on Mars. Great stuff.
Yeah, some of the stuff that's on board, I am very interested in, like the RTG on there is longer term.
Is it a longer term one? Is it?
It is. It's a different RTG.
Right.
I think it uses a different isotope.
Different Peltier device or isotope in it. Yeah.
I think it's a different isotope in there.
Right.
There was a really good video from one of the engineering channels I follow. I'll link it in. But it was just going over all the things that were on board. So that was one thing that was really interesting. And the oxygen generation. Did you read about that?
Oh, because they're doing some test to see if they can produce oxygen or something, aren't they?
Yeah, they're basically like cracking CO2. And there's like an electrode and they have to pump a bunch of power through it. Yep. And from a power perspective, it was interesting because like I think the solar panels can do like 150.
Right, that's probably so that's why they needed more power, is it? Is because they're going to chew a lot of power for this experiment.
Right. So yeah, I mean, kind of like your solar panel thing at home, right? I mean, like you only have so much power right now that can run the air conditioner and the washer and dryer and all that other stuff, right? And they're working under similar budgetary constraints from a power perspective, in that this thing needs a ton of power. So I think they had something like 150 watts of solar available, but this thing needs like 180 to start working. So they're gonna bank the power with cells on board, and then when they have excess power, they can run the experiments. I think.
Hang on, the rover doesn't have any solar though. It's all.
Oh, sorry. Sorry. You're right. Sorry, not solar. It's from the RTG. Yep. That's right. So when they have excess power stored from the RTG, that's when they can run this experiment.
Right.
But basically, it's like there's like an anode, and they power it somehow, but it's actually going to generate atmospheric oxygen for future. They're testing it as like a way to potentially make air for future astronauts that might be there. But then also, if they can really start to generate more, then they could start to make propellant as well, because that's just like pure O2 for a return trip, which is like, man, that's some science fiction stuff, like that is friggin' cool.
You can make anything given enough power. Dude, you can make gold. You can manufacture gold if you've got enough power, right? It's just not economically viable to do it.
Right.
It's just insane. Yeah. You can manufacture diamonds, gold, all sorts of stuff. Yeah.
Right.
It's just,
I think it was the Real Engineering channel. So like I said, I'll link that in.
Yep.
But there's a lot of really cool science on board. I feel really guilty. I didn't know about what was going on. I think, what's his name? Veritasium made some videos about it a while back. And, it was just like the slow burn. And like, I just didn't really pay attention to it. Yep. And then like, man, coming up to it, I was just like.
And then the excitement happens. Yeah.
Yeah, exactly. Yeah, I think that's just kind of how it goes with you're not into the, some of these people it's like their full-time job, like many, many people. It's like, damn, it's so cool.
Yep.
But
that's great.
Yeah.
All right.
Science. I love science.
Other news.
That's great.
It finally had to happen. They finally had to fold. Fry's
Yeah,
Electronics
Fry's.
is no more. Yeah, this has been coming for
That's right.
years.
This is, I mean, yeah, this is the death of retail in general, right? But
yeah, no, Fry's has been, if you've been like, there's been all these people out there actually visiting the stores doing walkthroughs for the last 4
really?
years. Yeah, and they're just empty. Like the stores are just
Yeah.
empty and everyone knew it was coming.
Yeah, it's
know.
too bad. I mean, like,
and in fact, Fry's even pretty much announced that, well, the end is nigh. So yep, it's not surprising, but no, they are shut. Yeah,
they like a lot of these, brick and mortars in general, like especially computer stores at the scale they're at, it's like really tough to do. But I think the sucky thing for like obviously Radio Shack's long gone. Just having basically the electronics. If you're really in a bind, you're stuck with stores like this.
Yeah, you want to go down and pick it up.
Yeah.
Yeah.
You want to be able to get something. And literally this happened to me the other day. I needed a Raspberry Pi for a project, and I was able to. Micro Center is still around, which is a US based chain.
You're able to get one, yeah.
Yeah, I just ordered one and picked it up, which was super nice because they're all sold out on Amazon and everything else. So,
really? Okay.
Yeah.
Yep.
And I was able to get the same day. So that kind of thing, it's not often, but when it does, it's
when you need it,
really
you need
important.
It. But that doesn't sustain a huge business,
It does not, right? Yeah, me buying 3 Raspberry Pis at once is probably not going to
keep them afloat. Yeah,
right, exactly.
Buy more, Chris. Buy more.
Yeah.
So sadly, because I visited a couple of Fry's stores. We're talking 12 years ago now, and I was amazed. Oh man, it was incredible. But even then, at its peak,
they were like temples to nerds.
Temples to nerds. Yeah, it was, and they're all themed, and it was they were underwater theme, and there was an Egyptian theme one or something, and there was absolutely incredible. And they had everything. But even then, walking into it, I'm going, geez, they're overcapitalized on space.
Yeah,
I mean,
right, exactly.
I know this is the US and you got a lot of space in your cities and stuff, but geez,
I mean, how many people can you actually get through there to actually make enough money to support
but
it?
they like the checkouts, they'd have 40 checkouts or something. It's what, how many people do you expect to come through at once? It's just, I don't know. Yeah, they really seem to have been overcapitalized. So there is a lot to be said for a niche, thing. Because they try to do everything. You could buy white goods in there at the same time as you pick up your soldering iron and your components. Right, I mean, come on.
Yeah, and your gaming computer, that's
and your gaming computers.
Is.
You could build a computer from all the parts in there, and you could at the same time as you pick up a new washing machine. I mean, and a microwave. I mean, come on. No,
I think it becomes a supply chain issue in general too. It's just you need to make sure you have a couple. Our pack rat tendencies are going to actually pay off in certain ways.
Yeah, they're going to pay off sometimes. Yeah. Yes, they do. So all right. What else we got?
US is talking about boosting chip manufacturing. So there's been a couple things about this. We talked about Samsung last time, and there's been some US administration, talking about chip shortages. Obviously, we talked about last time you and I talked was about the chip shortages hitting the automotive industry.
Yep.
And that's usually enough to get governments around here paying attention. That happened back in 2008 too. Auto industry goes down, a lot of jobs go down in the US.
Right. So, a lot of jobs, and that means a lot of nasty letters. Yep.
Right. And if something comes out of this and that they actually start to bring chip capabilities back, I don't believe it, to be completely frank.
They're putting 37 billion into it, and a new plant costs 15 billion or something.
Yeah, exactly.
So it's it doesn't buy much.
Right. And really, 37 billion is okay, that's a lot. That's all right. That's a ton of money, right?
Yep.
That's like 2/3 of a Bill Gates on a good day.
Yeah, but still, these plants are so expensive, right?
Exactly. Right. Well, and just the startup time too. So this is not going to have any impact for years and years and years. So,
but you have to do it now. You've got to think beyond the current election cycle. I know that's a shock, right? For a politician to think beyond the next election cycle.
I do hope that there is long-term thinking about this sort of thing because one, I think there's a lot of, so like I've complained about on this show a lot too, from a business perspective, I totally get it. TSMC is monstrous. They're going to have the fast, the newest nodes. They're going to have the most capacity. They're going to have the best engineers. They're going to have everything you possibly want. If you are a chip manufacturer, they look like the answer, right? They are the Amazon of the chip world, right? But when AWS goes down, you are screwed. You are so friggin' screwed. And you know what? Same thing happens here when you're like centralizing for economies of scale. Yeah, that looks great until something happens. And like sometimes you have to have inefficiencies, and whatever that looks like, it's like it's an impossible argument to make. And yet when the shit hits the fan, someone's gonna be like, "Why did we do this?" And the answer is the economics. It's just like
But
it's just such a
you also have to remember, right, that you don't necessarily need these bleeding edge plants, right? Yeah, sure, okay, they can produce like the latest Intel processor and whatnot, but like, really, is the country going to end if people don't get their latest Xbox or get their latest gaming PC? No, but if you can't produce cars and white goods and other consumer products that use like lower end chips, but still important, right? I mean, it's like, you can.
So all the stuff we've had on the show, talking about like the Skywater PDK, all of the Google stuff, like all of those, they're all at 180 nanometers, I think. So like we're talking many generations back from what is the bleeding edge, and it's like that is capable. It's not everything you need, obviously. It's not.
That's all that automotive stuff, right? That's all of a shortage at the moment that all the manufacturers complain about, right? Then they're not using 5 nanometer, 7 nanometer bloody chips in their automobiles, right?
Well, I think they're using 45 nanometer, right? So TI's on 45 nanometer.
Yeah.
But I think that, it really comes down to like, what are the trade-offs then? It's like, okay, so maybe we can't make, maybe we should be designing in something that has a slower switcher or, like the less efficient switcher or something like that. Yeah, I don't know how you do that at like a system level, because at the same time you think about all the sales incentives that are there too, right? You think about TI engineer walks into Ford and they're not going to be hawking the thing at the fab that's going away in 5 years. They're hawking the newest part that's on the newest process, because that's also what they're incentivized. It's just like such a big tough system to work within, and like I get how some of it works, but it's still like there needs to be some kind of like backstop kind of thing. I wish there was. I feel like if you took 37 billion and they just like standardized footprints.
Right.
let's spend 37 billion and have someone standardize footprints so that I can just drop in a different part with the same footprint. Why does a boost converter need to have a different goddamn footprint every time? Just have the boost converter. I know this is.
There should be government regulation, is what you're saying,
I know,
Chris. There should be
this
government.
Is terrible.
Yes, the government need to step in.
No, but I want like a fallback. How about this, Dave? How about we have a fallback boost converter footprint, and I could put that on my board in addition to the fancy new footprint from TI or onsemi.
Well, you can put in a classic, one of the classic inverters from 1970. They still make them.
Yeah, I guess so. Yeah, I mean, I guess you could do that.
One of the classic switches.
Maybe something that's a bit smaller, a little bit, mid range.
Yeah, no,
I don't know. I don't know how this all works.
It's on you. If you design in the latest whiz bang weird ass footprint thing and you're tied to one manufacturer, well, that's on you.
Oh,
unless you absolutely have to. Come on. There's not.
No, okay, yeah, I agree. I agree with the premise. Yes, that is on you, but that's not fair to say that's on you because you didn't design in the 1970s thing, because that's just not realistic, right?
Come on. I mean, are power supplies that critical in most products that you can't put in at least something that's available with a standard footprint from several manufacturers? Come on. I mean, most people aren't developing products like that.
I mean, well, if we're going to go back to the beginning of the episode, you showed a part that was, a little zinc Xilinx processor.
Well, yeah, okay. That enables the product, granted.
Has a bunch of, it had like five or six PMIDs, PMICs around the thing.
Yes, okay. They could have used a separate FPGA, but even if they used a separate FPGA, you're still tied into that one vendor, right? It's but we're talking power supplies here, dude. Right?
I don't know, man.
We're talking power supplies. Come on.
There is literally no answer here, but it's just I wish there was. Dave, I just wish there was a chip printer, Dave. You know what I really want?
Oh yeah, it's coming next year because you predicted it 12 years ago. So it's
I literally had that thought at one point of like, oh man, that would be nice though. I know it's never coming, but it would be nice.
Oh, you admit it's never coming now. You use the word never. You finally admit after a decade that I was right.
Maybe Dave, maybe.
Hallelujah.
But
That's it.
But it would be
That's
nice.
it. Okay, the amp hour's over. That's it. We're
say,
done. We've come full circle. Chris is finally
It would be
there.
nice. It would be nice. Wouldn't it be nice if there's a chip printer?
Because we had that song in a commercial here. Was it Cadbury's? Wouldn't it be nice if the world was Cadbury's?
Beach Boys, yeah.
You know, and it's
Oh,
like,
really?
it's like, everyone, when you think of that song here in Australia, you think of the TV commercial, unfortunately. For chocolate. Yeah. It's been hijacked. Boy. Anyway, is that it on our news list? There's a couple of other items, but
a couple other items. Yeah. Go check out the subreddit. That's what it's there for, folks.
Yeah, and exactly.
Drop your links in there too. You know, we love to hear from people. Like, you know, people send me links sometimes on Twitter or elsewhere, which is great. But man, if you want more people to see it, it's open. Just go on Reddit. If you don't have an account, just
you can post it there yourself, and then people will thumbs it up. And yep.
Yeah, exactly. I mean, and there's comments on it too. You can go and discuss things. You can talk about it before we get to it, and it's sweet. It's great.
So there's 40. How many members here? 4,300 members on the Reddit. 4.5K, 4,500 members. Nice. 10 people online right now viewing it.
Right. They don't even know.
As
we're watching
shooting
them. Yeah, we're watching them.
There you go. Yep. I can stalk you. Well, not really.
Yeah.
No.
All right, Dave. Well,
that's it.
Go buy another Blackmagic switcher, the non-ISO version, and open that one, and then do a comparison. And
right, okay,
I'll be happy.
You. Yes, I'll go spend $800 and do a
comparison.
Yeah.
You got it. You got it sitting there. Come on.
Oh boy, can we talk about what I got offered the same day I ordered that?
Yeah, sure.
Literally, like a couple of hours after I spent my $1,200 and ordered my Blackmagic switcher, I was contacted by the Blackmagic distributor here in Australia, and they said, "Hey, we heard you mention it in the last video I did. Was it I don't know, I mentioned in some video somewhere, and that I was possibly going to get one. And they said, "Hey, would you like us to send you the new model?" And say, "Oh shit, I just bought."
You should see if they can send you the old model and just tell them you're going to tear it apart. You know, like it's great. I'd be interested.
Yeah,
just tell them.
Okay,
they probably have some sitting around.
Yep.
You know, like that's great.
There's an interest. Okay. Yeah, I'll see
just
if I can.
Tell them you're going to reveal all their company secrets except for the bit streams and all the code and all the other stuff that's inside. So,
because I held off getting one because news was coming out that they were going to do they had a press conference for a new talking about this. So I thought, there's a new model coming out. Sure enough, there was a new model, but it's like an 8-channel job, which I didn't need. So anyway, very cool. All right, that's it.
All right, man. See you.
Catch you next time.